Okay, this is Geometry Review 4, and we're going to discuss questions on Review 1, 2, and 3. Okay, that'll include lines, polygons, triangles, circles, quadrilaterals, and the solids. Okay, first question. Find the area of a rhombus if the side length of the rhombus is 5 centimeters and one of the angle is 60 degrees. So if one of the angles is 60 degrees, and if you recall the properties of a polygon, of a rhombus, sorry, then in that case, you'll know that opposite angles are equal in a rhombus. Yeah. So if that's my rhombus, and if this angle is 60 degrees, for example, then this is also 60. You also know that rhombus is a quadrilateral, therefore the sum of the interior angles should add up to 360 degrees. So 120 goes here, 240 remains. So this is 120, 120. So there are two ways to solve this question. We know that the side length is 5 centimeters, correct? So if we divide this from the 120 side using a diagonal, then we know that these two angles will form 60 degrees because rhombus has perpendicular, the diagonals in rhombus and in parallelogram and in a square, they bisect the angle at the vertex, not in a rectangle though, correct? So the diagonals bisect the angles at the vertex and they're perpendicular bisectors. So now we have two equilateral triangles, and we know that equilateral triangle, the area is root 3 by 4 times side square. So it is root 3 by 4 times 25, and that's the area of one of the triangles. So there are two of them. Therefore, the answer is twice root 3 by 4 times 25. Many ways to work this out. Instead of root 3 by 4 times side square, which is the ready-made formula, you could also use this base. You can use 30, 60, 90 because this is 30 degrees out here. So 30, 60, 90, and then multiply it by 4 if you like. And you can use that also. So you can work it out at your own convenience. So the answer is therefore root 3 by 2 times 25, which is D, square centimeters. Okay. Question number 2. If the length of a rectangular garden, so we form a rectangle first. Yeah. So if the length of the rectangular garden is 4 feet more than its width. So if the width is W, then 4 feet more is this. Find the diagonal length of the garden if the area of the garden is 192. So the area is 192. So we know W into W plus 4 there is 192. And then once you get the width, we'll get the length, and then we can find out the diagonal. Yeah. So that's W square plus 4W is equal to 192. Yeah. So that's W squared. It's a quadratic equation that we've got to solve. And 192, we'll find out the factors. And we know that 14, 192. Okay, we'll just work out the factors first. So 2 times it would be 86 or 96. 96. It'll be 2 times 96. Yeah. And then that would be, 96 is further broken down into 2 into 48. So that'll be 4 into 48. And then it'll be 4 into 6, so 16 into 8. What we're looking at basically is to get 192 such that the product is negative 192 and the sum is a positive 4. Sum and product. Yeah. So we'll further break this down. Let's see if we can think of anything else. 16, 8, difference is 8. We need 4. So how about here? 4 into 8, 4 into 4. Okay, I made a mistake out here, I think. It'll be 4 into 4, 12. So it'll be 12 out here, my bad. Right. So 16 tens are 160, 16 to the 32. So it's 160 and 32 is 192. So we can put a negative 12. So we know that x plus 16 into x minus 12 is equal to 0. That would be the factorization of this quadratic equation, where the product is 192 and the addition of 16 and minus 12 is plus 4. So therefore, we get x is equal to negative 16, x is equal to plus 12, and that plus 12 will be my w. Yeah. So obviously, this would be x would be the w. My bad. Yeah. So w is that is w. So that will be W is 12 and this is 12 plus 4, 16. So my diagonal will be 12 square plus, or in other words, you can also use a 3, 4, 5, I believe. Yeah, that would be my diagonal square, right? So 144 plus 256, and that is 400 d square. Therefore, d is 20 feet. Question number 3. Okay, so we have a diagram shown above, AC and CE. AC and CE are two of the x diagonals found in the regular polygon ABCDE. What is sum of the angles CDE, that is this one, and X, that is the number of diagonals out here? Two of the x diagonals found in the regular polygon ABCDE. So we all know that a pentagon has a number of diagonals. There is a formula also, and you can literally draw it and see for yourself. So here, look at this. If I were to just literally draw the diagonal, so there is AC and CE, two diagonals. Okay, I'll use a different color. So this is my third diagonal, fourth diagonal, and fifth diagonal. So there are 5 diagonals and forms a star. So x is 5. Another way to get the number of diagonals is using the formula number of diagonals is n minus 3 into n by 2, where n are the number of sides. So sides are 5 minus 3 into 5 by 2. So this 2 and 2 cancels. We got 5 as the number of diagonals. And it's a regular polygon, which means that all the angles are equal. So all the angles, yeah, that is these angles out here, C, B, A, E, and D, they are all equal. So we know that the sum of the interior angles of a polygon, yeah, n-sided polygon is n minus 2 into 180. So that is 5 minus 3, sorry, 5 minus 2 into 180. So that is 3 times 180, 540 degrees. Divide that by 5. So 108 degrees is what we get as what is the sum of the angle CDE, CDE. So that is 108 plus 5 is 113. So D is my answer. Fourth question. Okay. Right. So in the fourth question, they've given us two parallel lines, yeah, and a transversal line passing through them. So that is your transversal line. Find the sum of J, that is this angle, J, and G, that is this angle out here, this angle out here. So I'll use a blue color. So they want the sum of this G and J. That is how much. So I'll redraw it for you. So we have M is 55. So they've given us uh, this one out here and this one out here. Yeah. Triangles PQR. So this is PQQR and MQL, MQL. So these two triangles are congruent, meaning PQR, triangle PQR is congruent to, meaning identical to triangle MQL in that order. Okay. So what does it tell you? It tells you that first of all, we know that these two angles are equal. Yeah, because they are vertically opposite angles. Okay. Right. They've given us this as 55. Yes. So if this is 55, PQR, therefore the angle at M is also 55. This is also 55 because they're congruent. It's congruent. A is 65. So A is given out here. This is 65. Yeah. So this is also 65 out here. Understood? And therefore this is also 65 out here. In parallel lines, these two angles are interior alternate angles. These two. So the angles in yellow, they are called interior alternate angles. These two angles are interior alternate angles between two parallel lines. Yeah. So now we know that the G angle, okay, so I'll mark it in blue. This G angle, therefore, we know 65 and 55 is 120. Therefore, the G angle is 60 degrees, correct? And the J angle, yeah, is obviously 180 minus 55, that is 125 degrees. That is 125 degrees, okay? And hence we get 185 as the answer, delta. Okay. Um, Question 5. If the solid sphere with radius 6 inches shown above shrunk in volume by 50% to form a smaller sphere, then what is the total surface area of the smaller sphere? So total surface area. Right. So out here we'll use the similarity property. Yeah. We already know that if there is a circle, yeah, and if the radius is 3, let's say, and if it's a bigger circle with radius 6, then the ratio of the radii is 3 is to 6, which is also the ratio of the circumference. If I square this, it becomes the ratio of the areas. And if I were to cube this, it would be the ratio of the volumes. If that was a sphere, if that was a sphere, then in that case, if I take the ratio of the radii and I cube it, I get the ratio of the volumes. Using this concept, yeah, using this concept, we'll move ahead solving this question. We'll solve this question using similarity also. We'll solve this question without similarity also. Okay. So I need more space. So I'm going to delete this part. Right. Right. So using the similarity concept, okay. So we know that radius of the smaller sphere x, let's put it that way, and the radius of the bigger one, if I cube it, then I'll get the ratio of the volumes, which is 1 is to 2. Why 1 is to 2? Because it shrunk by 50%. So if the original volume was 2, then half of it will be shrunk by 50%, right? Correct. So now solving this, x cube upon 216 is equal to r. Yeah. Therefore, x cube is equal to 108 and that I can write it down as 27 times 4. 24 the 80 and 28. Okay. So therefore I get x is equal to cube root of this is 3 into 4 raised to 1/3. Yeah. Now I know that the radius, so I took radius, x is radius and 6 is radius as well for this one. So I need to find out the surface area. Surface area is 4 pi r square. So that is 4 pi x square, or this is the radius. So it will be x square. So it will be 4 pi 3 square and 4 to the power 2/3. Okay. Why 2/3? Because squaring 4 raised to 1/3 is 4 to the power 2/3. And therefore my surface area is, this is 9 pi, and you can see 9 pi out here. So that will be my answer basically, but I'll just show you the breakup. So this 4 raised to 1 and 4 raised to 2/3, right? So remember, if you have a to the power 2 into a to the power 1, it becomes a cube. We add up these two. So similarly, if you add up these two, we'll get 9 pi 4 to the power. This is, remember, 2/3. Okay, so 1 plus 2/3 is 5. And that's my answer. C. Okay, now what we're going to do is we are going to solve it using without the similarity. Okay, without similarity. So without similarity, we are directly going to take the volume and solve it. Yeah. Okay. So volume of the bigger sphere is 4 by 3 pi r cube. So that's 4 by 3 pi 216. I'm sorry, 6 cube. 6 cube, which is 4 by 3 pi 216. Therefore, the volume is 3 sevens are 3 twos are, and that's 288 pi. And the new volume, which is the shrunk volume, is reduced by 50%. So that'll be 144 pi. So 144 pi is equal to 4 by 3 pi r cube. And therefore, we'll work out the r cube. Once we get the r, then we can work out the surface area. Okay, so this is 4 goes into this 3 times, and 8 no, 6. 4 3 the 12, 24, 4 6 are. And 36 3 the 108. Correct? R cube, right? So this we already knew. R is, 27 times 4, right? Therefore, R is 3 into 4 to the power 1/3. So we know this R already from the previous similarity case. Therefore, the surface area will be the same thing as that one. I'll just write it down again. Yeah. 3 square into 4 to the power 1/3 square. 4 pi 9, 4 to the power 2/3, and that is 9 to the 9 pi, and then 4, 1 plus 2/3 is 5/3. So again, we get the same answer. Okay. Right. So I think we stop here and continue with the remaining questions in my next review 5. Yeah. Thank you.